Welcome to This Explainer. Today we're going completely behind the curtain to deconstruct the ultimate modern magic trick. It's an illusion you probably experience dozens of times a day without even giving it a second thought. Your device predicting exactly what you want to say, right before you've even finished typing it.
I mean, really think about it for a second. You type a couple of letters, and suddenly the rest of the word, or sometimes even the entire next sentence, just magically materializes on your screen. So how does your phone actually know what you're typing before you do? We totally take this for granted, but creating this everyday illusion requires some truly mind-bending engineering, massive scale, and a really delicate balancing act that's happening right under your fingertips.
And here is absolutely the most staggering part of that entire balancing act, the speed constraint. For this system to actually feel like magic, it has to happen in literally less than 50 milliseconds per keystroke. Faster than the blink of an eye, the system has to read your mind, check the context, ensure your privacy, and serve up a useful suggestion.
So here's our blueprint for today. We're going to cover the 50-millisecond magic trick, predicting the next word, decoding the noisy channel, generating the smart reply, the privacy and safety shield, and finally, guardrails and future evolution. Let's dive right in.
Section 1. The 50-millisecond magic trick, balancing the core goals. To pull this off, the core objective is incredibly demanding. The system has to predict text with very low latency, strong privacy, and high acceptance. And by high acceptance, we basically mean saving you keystrokes by giving you suggestions you actually want to use. But here's the immense challenge. How do you provide highly relevant, personalized suggestions to millions of people while strictly protecting their super sensitive private data, and do the whole shebang in under 50 milliseconds?
Well, the answer lies in a very specific pipeline. Think of it kind of like a VIP nightclub. Step 1 is the fast candidate source. This is basically the massive crowd gathered outside the club. Step 2 is the language model ranker. Think of this as the VIP bouncer who decides who actually gets to go inside based on how cool, or in our case, how relevant they are. And step 3 is the safety filter, the security check ensuring nothing offensive or dangerous makes it through to your screen. This retrieve then rank pipeline is the secret sauce. When we actually map this architecture out, you can see how beautifully orchestrated it all is. As you strike a key, the context hits an on-device model and cache for instant suggestions. Simultaneously, a candidate source throws out thousands of possibilities. Then, the language model ranker scores them based on likelihood and personalization. Finally, it all passes through the safety filter before it appears as a suggestion. It's this incredibly complex, orchestrated dance happening locally on your device whenever possible.
Section 2. Predicting the next word. Autocomplete.
Okay, so when you type a prefix, let's say the letters W-E-A, how does it grab the candidate so impossibly fast? Well, it uses something called a prefix trie. This is a fast, pre-computed tree structure. Remember the crowd outside the club analogy? This is it. It instantly retrieves a massive list of popular completions, words like weather, wealth, or weapons, along with their historical frequencies. It's lightning fast because, essentially, it's just a giant, highly organized lookup table.
But here's the thing. A raw lookup table isn't really smart enough on its own. This is where that retrieve then rank approach really shines. Once the prefix trie grabs those raw candidates, the language model, our VIP bouncer, takes over. It ranks those candidates based on likelihood, recent trending freshness, and even your own personal on-device style, making sure the absolute best suggestion wins. And again, it does this primarily on device for privacy.
Section 3. Decoding the noisy channel. Spell check.
Now, engineers frame spell check as a noisy channel problem. Instead of just looking up if a word is in the dictionary, it uses a brilliant mathematical model. It combines a language prior, which is what you probably meant to say based on standard language rules, with a keyboard-aware error model. This is wild. It literally calculates the physical distance between the keys on your screen. It figures out the likelihood that your thumb just slipped from the S to the D key, rather than assuming you actually meant to type a completely fabricated nonsense word.
And here is a totally vital piece of the spell check puzzle. Context is everything. The system uses the surrounding words to figure out the correct fix. If you type, "I want to read a book," the system looks at the word book and immediately knows "rees" should be read, not real. This context-sensitive correction makes the system exponentially smarter than an old-school dictionary lookup.
Section 4. Generating the smart reply. Curating conversations. Now we get to smart replies, where a fascinating engineering trade-off happens. Developers really have two main options here. They can use retrieval and selection, which basically means picking from a pre-written, curated list of common replies. Now, this is super safe and very fast, but it's kind of limited, right? On the other hand, they can use an on-device generative language model. This actually generates new, highly contextual text on the fly. It's way more flexible, but it carries a much higher risk of hallucinating weird or unsafe text, so it requires some really heavy filtering. Section 5. The Privacy and Safety Shield, Protecting User Data. To actually get smart, these systems have to learn from vast amounts of data. But text messages and emails? That's some of the most private data on Earth, so the rules are incredibly stringent. Engineers are bound by severe constraints. They literally must avoid central logging of raw chat data entirely. They have to utilize on-device history so your personal style stays on your phone. They apply complex mathematical noise called differential primacy to any aggregated data. And of course, they must aggressively filter offensive text. So, how do they actually solve this privacy paradox? The absolute hero here is federated learning. Instead of sending your private text messages up to a cloud server to train some massive brain, the main system sends a tiny copy of its brain down to your phone. The model learns directly on your device, from your unique typing habits. Then it only sends aggregate, totally anonymous mathematical updates back to the central system. It learns your style without ever exposing your embarrassing typos or private secrets. It's pretty genius.
Because the underlying rule is just non-negotiable. Raw email and chat must not be centrally logged. Since Autocomplete learns from generalized data, there's a very real danger it could surface biased, offensive, or privacy-leaking suggestions based on other people's data. This is exactly why that strict safety filtering step we talked about earlier is absolutely paramount. It's the vital shield between raw internet data and your personal screen. Section 6. Guardrails and Future Evolution. Failure Modes and Future. But look, even with strong shields, things can definitely go wrong. And if there is a cardinal sin in keyboard engineering, it's this. Beware overcorrection. Engineers note that an aggressive autocorrect that forcefully changes a correctly typed, perhaps obscure word into something else is incredibly frustrating. In fact, it's actually worse for the user experience than just leaving a typo alone. Frustrating the user instantly breaks that illusion of magic we've been talking about. Because of that, the mitigation strategy is super clear. The system must constantly track its wrong correction rate. And when the model is in doubt about a weird word you've typed, the guardrails kicks in. It should always bias toward gently showing you a suggestion that you have to tap to confirm, rather than silently and aggressively overwriting exactly what you just typed out. And man, this system has grown incredibly fast. We've moved rapidly down a timeline from the minimum viable product of simple dictionaries and basic tries to V1 with neural language model re-ranking. Then came V2, unlocking that on-device federated learning we just discussed. And right now, we are crossing into the advanced stage, featuring genuinely powerful generative compose models running right on our phones, completely blurring the line between a simple keyboard and a proactive AI assistant. Which leaves us with this massive, really provocative thought to end on. Our keyboards are no longer just dumb grids of letters. They are highly advanced predictive AI models making complex decisions in under 50 milliseconds. They don't just type for us anymore. They actively suggest what we should say. As these systems continue to evolve, you've got to wonder, how much of our daily human conversation is already being gently steered by a 50-millisecond prediction? Thanks for joining me on this explainer. I hope it completely changes how you look at your screen the next time you send a text.